Hi everybody, in this video I'll be teaching you how to write a basic line follow. In FLL we have lines that are black and white, and these lines are often the things that you will be driving off of. Why is it so important to drive off of these lines? Well, it can help your robot reposition, it can help your robot stay on track to where it's supposed to go, and finally it allows you to drive way more accurately than simply just using a tank drive. If you're here just for the program, here's the basic program. I'll show it on screen right now. But hopefully you stay longer and I can explain how this line follow works and how, more importantly, you can understand the concepts so you can write your own in the future. We have this black line here, right? And under normal circumstances, we can just drive straight. However, one problem with the EV3 system is that these wheels right here have a little bit of play. So you see how I'm not moving the motors, but you can still hear faintly the wheels are moving and turning. What this means is it will never drive completely straight without the use of sensors. And one of the most basic sensors and most commonly used sensors is the color sensor right here. Now, we've used it before to drive up to a line and stop, and that's basically the only thing we've used it for other than measuring like light and stuff like that. However, we can use the color sensor to drive accurately and straightly along this black line. And we're going to start off with the basic line follow, which basically what it does is it follows on the pathway or in the middle of this black line and the white. And that should give us what we call a mid value, which we've calculated in previous episodes. So we're going to follow along that mid value all the way over. So let's head to the computer and see how we can do this. So because we're starting off a completely new project and we're basically just going to have this one program be a project, let's open up a new one. So instead of going to your Control O and opening up our EV3 tutorial, we're now beyond that. We're going to add a project, and this is brand new, a blank canvas. The first thing you want to do is set it up properly. Control Shift S or Command Shift S if you're on Mac, and you can rename it Basic Line Follow, because that's the name of our project. And you can name the program here the actual line follow, or I just prefer to use LF. And a lot of the times you'll hear the term LF. It's basically just short form for line follow. The first thing you do, obviously, connect your robot, and let's analyze this really quickly. Remember how we said that the robot had to turn a certain way if it sensed a reflected light intensity under the mid value, and turn right if it was over the mid value. There's a variable here that we have to determine, which is the mid value. We'll do that in a second, but let's just assume the mid value for now is a 50. We're just going to do, let's just say this. High is 100, low is 0, and of course mid is the mid value, so the average, which is 50. We're going to use these set values for now. Probably in another video, I'll be explaining how to tie in the variables and stuff like that into this program. So let's actually just set the variable as 50. We'll add a new variable, we'll do mid, and we're literally just going to put in 50 for now. We can change this value later, of course. So the first thing we want to do is, because the robot is making a set of decisions, whether or not it wants to turn right or left, we're going to add in the switch block, because it's the only logical choice here, right? If it does something correctly, or if the reflected light intensity is under the mid value, it's going to do this action, and if it's over, it's going to do the other action. Switch it, of course, to color sensor, because that's the thing we're using. Compare and reflected light intensity. What this does is it, again, checks the mid value, sees if what it's reading right now is higher or lower than the mid value. So, because we have our variable here, we're not going to change this, we're just going to plug our variable straight into it. Remember to use the read variable, you can plug it in here. So now what the switch is asking you is what the color sensor detecting right now they're less than our mid value. So if it is less than, remember how black, the darker or the blacker something is, the reflected light intensity is less because there's less light bouncing back to the sensor. And if there's more light, then of course it's going to be white. So basically what it's asking right now is the current thing that it's seeing more black than white, or more black than gray, like middle part of black and white, like perfectly middle gray. If it is, then what should we do? Now, we'll assume that we're on the right side of the line. So here we have our robot, right? And our color sensor, basically, if it's over a black line, we're going to tell it to move towards a whiter side, because the only way you can have a perfect balance of the color sensor is when it's at this specific position, halfway on black and halfway on white. So if it's on black and we want it to follow along this side of the line, like so, like that, we're going to teach it to turn to the left, or like as you're viewing it, the right, but the robot's left. So we're going to make it drive like that. And if it's too much white, of course, we do the opposite. We want to achieve a gray value, a middle value, so we're going to train it to move to its right. We're going to go with the robot's direction right here. So basically, the robot's going to start, if it starts on white, start turning, and oops, it's on black, it's going to turn back out to white, oops, it's on white, turn into black, turn into white, turn into black, and stuff like that. And every single time it compares the mid value, or the gray area of the line, to decide whether or not it's going to turn towards the black or turn towards the right. So now let's go over to the computer and see how we can actually code this. How do we implement the movement I just explained to you into the actual program? Well, inside our switch block, I'm going to label this top one already as our if sensing is black. And I'm also going to label the bottom if sensing is white. This is an easy way, especially if you're starting, to basically organize your program into something and not necessarily have to go back and read what the program does every time. Instead, you can use actual English and not have to decipher it over and over and over. So if the sensor is on black and we want the robot to follow on the right side of the line, we want it to turn to the right, because that means if we're two on the black side, that means we're in danger of going off the line. We want to turn back to the right side. So here, drag your large motor block, set it to whatever port your right motor is on, because you want it to turn to the left using the right motor. Mine happens to be C, and basically if the sensor is black, it's going to make this option. We already know about switches. You can control click the same one or just drag in another block, and be sure to change the motor. So now what it does is, if it currently senses a black, it's going to turn to the right. If it currently senses white, it's going to turn to the left. However, we check our rotations and we actually see that our rotations are too much. And so we're going to lower it drastically. Remember, we want the color sensor to always be running, or running as much as possible, in order for us not to overturn and to keep the sensor on the line. So I'm going to set it to 0.05, which is a pretty small number, rotations of course, and there's one more thing to do. Remember how this program will only run once, which means that we're only going to either rotate the motor C 0.05 rotations or B 0.05 rotations. Of course, we want to follow the entire length of the line, so we're going to add in a loop. I'm going to keep only my switch inside the loop just for ease of reading. So you can disconnect this wire, put the switch inside the loop, and you can drag the variable actually into the loop. So you drag this wire, bring it down under, and you can just plug it into this, just like it's almost like the loop is in there. But now you have your very, very basic line follow program, and I'll show you what it does. You can feel free to experiment with this on your own as well. I'm going to run my program now, and let's see what it does. Now remember, we're following on the right side of the line, so you want to place the robot on like anywhere here on the right side of the line. If you put it here, what happens is it can't find a line, because it's by default, if it sees white, it's going to turn this way towards its right. So you can run it. It doesn't even have to be on the line. And you can see our robot is going to alternate between white and black, white and black, and white and black, just like we told it to. As you can see, it's pretty choppy, it's pretty slow, but it follows the line well enough. If we started on even the black part of the line, which I'm doing now, it's going to turn that way toward its left and go back on course, just like so. Which means our line follow works decently well. So in order to test your line follow accurately, or more accurately, we can see what happens when the robot encounters something like a curve or something like a jagged edge. This way, because the line actually alternates, you run the risk of your robot seeing full black here, turning right, and not turning right enough or something. And you run the risk of it just driving off course. This happens quite a bit and often occurs through trial and error, and often you can point out when the robot is really close to dropping off the line. So run your line follow just like normal and observe what happens. Right, the robot readjusts course and it readjusts it decently well. This is because we are riding along the left side of the line, or from our perspective, the right side of the line, this side of the line, and therefore, if it sees black, it's just going to calculate and it'll go along with the line because here it's seeing black, 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 and it's turning in the direction of the line. It's going to keep turning, and now it's in between the line, just like that. However, if I swap the line, let's see what happens. Now let's see what this does. Run your program just like normal. And our robot actually overturns. Now, if there were a black line here, it would have most likely caught it and continued on. But this essentially means we're not turning enough because as soon as we reach here, we see white, we're turning, oops, and we're missing the line up until here, right? So we can make a tighter turn. However, this is what happens when you write a basic line follow. This can be easily solved by something called a proportional line follow. I'll get into that in a later episode, but let's see how we can optimize this as best as possible. Let's see how we can make this both at the same time faster and smoother. Now, remember how our line follow is incredibly choppy? Well, we can solve this by changing our inside blocks into something like, I don't know, a move steering block. This means that we can turn and at the same time move forward with both motors. We're going to set it to, I don't know, because here we want it to turn again to the robot's left. We're going to do, I don't know, -30. And we're going to cut the power down a little bit to 30, and we're going to make the rotations 0.05 again. Do the same thing on the other side. Don't forget to reverse the direction, and we'll run this and see how it does. Let's run this new program and see how it does, right? Remember, it's moving forward and at the same time turning in and out of the line. So I'm going to run it from here. And as you can see, it's actually quite a bit smoother than it was before. Remember the direction of how it goes, and that curve was a lot less jagged and a lot less jerky than it was before. Keep in mind, however, that this is slightly less accurate because of the fact that you're covering more distance by moving forward and by turning at the same time. Now, if we wanted to swap which side of the line it was on, we would simply just switch the actions that occur, if it sees black or white, right? Because if now we see black and we're forcing it to turn to the robot's right, it means we're going to be following then on the right side of the line. You can do this whichever way you prefer. Just make sure you start your robot on that particular side of the line so it turns in towards the black line. Just a quick tip before we finish out this episode. If your line follow isn't working properly, I suggest you put your color sensor directly over black, directly over white, jot down the two values, find the mid value, and adjust accordingly. This happens quite often, and of course, with your mid value, you should be more than fine in terms of tolerance. You'll have most likely the proper amount. Try to check your lighting, check every single condition with your color sensor, see if it's on. A lot of the times people forget that it might be unplugged, or like even if the wire's a little bit frayed, that it won't connect properly, something like that might affect its performance. That being said, thank you so much for watching, and I'll see you next time on how we write a calibrate to complement this beautiful line follow. Until next time, bye bye.